All right, so we're going to start this off by looking at your degrees and radians. So you've already seen degrees before when you were in geometry. What we're going to do now is kind of relate that a little more to pre-calculus and what we're going to be looking at over the next several weeks and months. Okay, so in this top part, it says for degrees, a circle is comprised of 360 degrees, which is called one revolution. So if we were to go starting from the left side over here, excuse me, right side, and go all the way around your circle, it would be 360 degrees total. So one revolution is equal to 360 degrees. We might need that later. For the next part, it says the unit circle has a radius of 1 unit. We're not going to focus too much on the unit circle today, but this is all leading up to the unit circle itself. So if the unit circle has a radius of 1, it says this, we need to find first the circumference. Okay, well, if the radius is equal to 1 unit, and we need to find the circumference, the first thing I need to know is what is the circumference. So Melissa, what's the equation for the circumference? Give me something. That's exactly it. Good job. What's pi r squared? Not just Melissa. What's pi r squared? Not diameter. Say it again. No. Pi r squared. What is it? Area. That's your area. So pi r squared would be your area. So for the circumference with a radius of 1, we could plug in that 1 and simplify. So the circumference of an entire circle would just be 2 pi when your radius is 1 for your unit circle. For the next part, this one is asking for the length of a semicircle. Okay, Heidi, what's a semicircle or semicircle? Half a circle. So if I take the circumference formula that Melissa just gave me, and I take half of it, so 2 pi r divided by 2, we're still using that same radius of 1. So we're going to do 2 pi times 1 over 2. That 1 isn't really going to change anything. What happens to the 2's? They cancel. So I'm just left with really pi, because 1 times pi is just pi, and 2 divided by 2, these cancel. So when you have a semicircle, looks like your length or your circumference is going to be about pi. The last part of an arc by a central angle of 90 degrees. Okay, so we need to do the same thing, same radius, but this time it's going to be 90 degrees. Okay, so if you think back to geometry, central angle is when you have a pretty much 90-degree angle in the center of your triangle, or excuse me, the center of your circle. So starting from this initial side going over, this is going to give you 90 degrees. Okay, we already talked about a semicircle. That's half of a full circle. How much is this 90 degrees part of your circle? Like how much is that in your circle? Say it again. It's about 1/4 of your circle. So for this one, when you have your 90-degree angle, we're going to make that 1/4 of the 2 pi r. Okay, well, we already said it's going to have the same radius as what we've been dealing with. So I'm going to make this 2 pi times 1 over 4. 1 times pi and 2 is still going to be just the 2 pi at the top. What's 2 divided by 4? Which one? 1/2. So we can write this as 1/2 pi, or you can write it as pi over 2. I'm going to write it as pi over 2. There's methods to my madness. So for that 90-degree angle, I'm going to keep that pi over 2. We can keep doing this forever, but all we're doing is we're just taking that whole circle and we're dividing it into smaller and smaller pieces. So in a circle, it can be divided up into degrees, 360 units, or it could be divided into radians. What you just found are the beginning portions of your radians. So when you have a full circle, 360 degrees, it's the same as 2 pi. When you have half of a circle, or semicircle, that's pi. And when you have 90 degrees, this is pi over 2. These are not degrees, these are in radians. So all of these, when you see that pi, is in radians. I think I said 2 pi degrees, I meant just 2 pi, not degrees. Okay, so what is a radian? These 3 statements that I'm checking pretty much mean the same thing, so I'm going to kind of summarize it into one big thing. As you rotate around your unit circle, so as you rotate around it, the degrees that you would normally get, we're just going to write them in radians. Degrees and radians are very similar. It's literally just creating an angle and you're writing it with the pi. That's all you're doing. It's really not anything too crazy. So it specifically says 1 radian is an angle of an arc that is created by wrapping the radius around its circumference, which is what we just did. So this little arc that we just created, this is an angle. That's all it is. And we just wrote that angle in radians with that pi. There's a couple other things that I'm going to mention. 1 radian is equal to 180 over pi degrees. I'm going to actually give you something easier to memorize instead of this. And it's about 57.2 degrees. I don't give you guys anything that needs that 57.2, so don't stress about it. There are 2 pi radians in the unit circle. So that means in a whole unit circle, as it goes all the way around, this is 2 pi radians, which is equal to 360 degrees. So in other words, the full circle. It goes in a complete circle. And the last part is no unit of measurement is typically written. So you know how like for degrees, we put the little degree symbol. For inches, we put IN. For radians, you really don't need to write radians. But for now, I'm going to do it just so you understand pi represents the radians. Okay, so we talked about a couple of things. We said 2 pi radians, or 2 pi, is equal to 360 degrees. Half a circle, we talked about this earlier. Half a circle is not a full one. So how many degrees is that? 180. I'm not going to put degrees. So 180 degrees because it's written out. How many radians is that? Pi, because we said up here, half of a circle, which is 180 degrees, is equal to pi. This little conversion here, 180 over pi degrees is equal to 1 radian. I don't like having that fraction because odds are if you have that fraction, you're going to mess it up somehow. If I was to multiply both of these sides of the equation by pi, I'm going to have 180 degrees is equal to what? I multiply both sides by pi. What's 1 times pi? Just pi. So make your life easier. Instead of having to memorize this ugly fraction, just memorize this. This is one thing that I actually want you guys to commit to memory. And you'll see why when we get to the bottom of the page. Okay, so we've talked about a few things right now. We've talked about what radians are. We've talked about how they relate on your circle, how to find them. What we're going to do now is pretty much relate all of these units in radians into degrees, because I want you guys to see exactly what those look like. So for 2 pi, we said it at the very top of the page or earlier. 2 pi is the same thing as how many degrees? 360. So that's pretty much starting from your initial side and going all the way around your circle, the whole thing. Giselle, what about pi? What's pi equal to? 180, which is half of a circle, so that's 180 degrees. So from here to here. What about pi over 2, Jesus? What do we say pi over 2 is? Say it again. 90 degrees. We said that at the very top. 90-degree angle, that's pi over 2. So that'll be about vertically, right about there. Oh, great. Pi over 4. What do y'all think? What do you think pi over 4 is going to be? 5. How'd you get 45? 180 divided by 4. Because remember, pi is the same thing as 180. Just take 180, divide it by 4. That's going to give you 45 degrees. That's about here. We can do the same thing for pi over 3. We could have done the same thing for pi over 2, but we had already calculated pi over 2 earlier. So pi over 3, I'm going to take 180, divide it by 3. So what's 180 divided by 3? 60 degrees. So that's going to be a little bit bigger than 45. So that's about 60. And then pi over 6, that's 180 divided by 6. What's 180 divided by 6? 30 degrees. So it's going to be a little lower. That should be my angle. Of course, I can keep going to like pi over 7, pi over 8, pi over 9. We don't really need to go through all of those. What we can do instead is I can show you guys how to always find your answer using something you learned back in IPC and back in, I don't know, middle school math. Using dimensional analysis, we can pretty much take degrees and convert them into radians, or vice versa. So let me refresh your memory on what dimensional analysis is first, and then we'll actually go from degrees into radians and radians into degree. So for this first question here, we have 300 hours, and we need to get to see how many days that is. So 300 hours, I need to transform that into days. What unit conversion can I use? 1 day is 24 hours. The issue is, where should I put like the day, 1 day? On the top. And in the denominator, we're going to have 24 hours. Why did the denominator need to have hours? So you can cancel out the numerator and denominator's units. So when I actually multiply that, I'm not going to multiply, then divide, because 300 divided, or let's try this again. 300 times 1 divided by 24. I don't want you guys to waste time trying to solve this. It'll be 25 over 2 days, which is about 12 and a half. It's about 12 and a half days. Okay, for the next one, we have 3 over 2 inches, and I need to transform that into yards. Okay, I'm not Google, so I don't know how many inches are in a yard, but I do know that there are 12 inches in a foot, and I know I can get from feet into yards afterwards. So you guys tell me, do I put the 12 inches in the numerator or denominator? Denominator, that is for 1 foot. Am I done with my conversion? What do I still need? The yards. Okay, so how do I get into yards? How many feet are in a yard?
28.
Is it 3? I think it's just 3. Last time I checked, I thought it was 3 foot. It's equal to 1 yard. 3 feet should be equal to 1 yard. So from here, I'm going to cancel out my feet again, and I'm going to pretty much simplify. 3 times 1 times 1, and then 2 times 12 times 3. Both of the numerator and denominator have a 3. Can I cancel these? Yes or no?
Yeah.
Yes, I can. Don't just cancel it because you want to. 3 times 1 times 1 over 2 times 12 times 3. This is why I'm canceling it. After you multiply, you're just going to divide them. So just cancel them. So this will give me 1 over 24, not days, yards. I know from the top part of the problems that we just did, I know that 30 degrees is equal to pi over 6. I know that. But if you didn't have this on a test or quiz, let me move this so you can see it. If you didn't have this on your test or quiz, I would want you to solve it. Look back at this whole page of notes. How can I get from degrees into radians? Don't look at me, look at your paper. How can I get from degrees into radians? We could use the 180 over pi, but what was the one I told you to use instead? 180 degrees equals to the pi radians, this guy here. If there's one thing that you try to commit to memory soon, it's this conversion here. It'll help you with getting from degrees into radians, not on your homework, but also on your tests and quizzes. Some teachers will tell you to just memorize the radians, memorize the degrees. That's too many things to memorize, guys. Memorize this one formula, and you can always solve for it mathematically. So for this guy, 30 degrees. Okay, so Jorge said there are 180 degrees in pi radians. I already know it's pi over 6, but I need to show it mathematically. The degrees cancel. I technically have 30 over 180. Okay, well, if I was going to divide those anyway, 30 over 180, those zeros would cancel, right? What's 3 divided by 18? 1/6. So I'm going to make that 1 over 6 pi, which could also be written as pi over 6. It's literally the same thing. On your tests and quizzes, guys, don't try to commit too many things to memory. Remember this one conversion so you can do the rest of them. Let's look at the next page. I'm just going to do that top portion for examples 1 through 4, and then we'll be done. As you notice, all of the practice questions on this page have what? They have the answers along this side here and along this side here. So obviously I'm not going to go through those because you can do those on your own, but we are going to do the ones at the top. I'm going to do examples 1 and 4. You guys are going to do 2 and 3. So for example 1, I'm going to keep the conversion at the top of the page that Jorge told me about. So 180 degrees is equal to pi radians. That will make it so much easier for me to solve. Okay, so I'm starting at 60 degrees, and I need to get it into radians. So we're going to put 60 degrees I'm going to use my conversion. 180 degrees is equal to pi radians. So 180 degrees, pi radians. I'm going to put RAD for radians because I'm too lazy to write out the IANS. Okay, so from here, I know for sure the degrees cancel. Yes? Yes or no? Okay, I have 60 technically. I have 60 over 180 pi, but I don't want to have those large numbers. The zeros can cancel because I can divide them both by 10. What's 6 over 18 reduce?
1/3.
1/3. This is the same thing as 1/3 pi, which is equal to pi over 3. On tests and quizzes, guys, especially if it's multiple choice, you're going to see it as pi over 3. All right. Like I said, I'm going to do 1 and 4. So let's look at number 4. Okay, so for this one, I'm going to have negative 7 pi over 3. This is in radians. I need to get it into degree. So, Jenny, if I was to write this out, where should I put the pi? Numerator or denominator? Denominator. And I'll put 180 degrees in the numerator. When you do that, guys, just because this one has a denominator of a number, don't put the pi in the numerator. Please don't do that. These pi's cancel, and I'm left with negative 7 times 180 degrees over 3. I'm not about to multiply 7 times 180. Can I reduce any of these numbers?
Yeah.
Which ones?
183.
What's 180 divided by 3?
60.
So now, what's negative 7 times 6?
400.
Negative 420. Don't forget that negative, guys. So 7 times 6 is just 42. Add that 0 to the end. That's negative 420 degrees. One last thing before you guys do examples 2 and 3. 420, is that more or less than 360? That's more than 360. And since it's negative, if you think back to the page that we just did, when you have a counterclockwise rotation that's negative, that means it's going to be going in a clockwise direction. Excuse me. Clockwise rotations are negative angle measures, so it needs to be going in a clockwise direction. So what this technically means is it started here, it went one full rotation around, that was 360, and then it just went a little bit more over to where 420 is. I'm going to say this is where 420. That's negative 420 degrees. So if I asked for you to figure out what quadrant that's in, you'd want to know this is the negative 420 degrees. That's where it's located, probably in quadrant 4 somewhere. So right now, I want you guys to do examples 2 and 3. Use that unit conversion and figure out what are the radians and degrees for those two. I'll give you about 2 minutes. Really quick. I got 270 degrees for number 3. Is that okay? What about for 2? I'm not going to keep this 45 over 180. What does that reduce to? Negative pi over 4. That should be your answer. The rest of those practice questions, guys, these are literally just extra practices you're studying for your tests and quizzes.